So these problems are based on board questions and which are very important. Please be careful while solving this, okay? And I'm going to solve some other problem also apart from this one. So let us go to the first question, okay? So the first question, it was asked in 2008. It is from Coulomb's law, okay? So it is not so familiar question, but also it is always better that you should learn the board questions. And please remember, the board questions are repeated. Please remember that. Okay. So two charges having equal charges separated by 1 meter distance. So there are two charges. Okay. And also remember the everything, the solution, the hint for the solution, all are given in the question only. So the two charges having equal charges separated by 1 meter distance experience a force of 8 Newton. So there are two charges and both the charges are equal in magnitude separated by 1 meter. So there are two charges. So let me write this as Q and another as Q because both are same, and this is separated by a distance of 1 meter, right? Now it says that it experiences a force 8 Newton. Here the force is equal to 8 Newton. Now the question says now, what will be the force between these charges when the medium is replaced by another medium of dielectric constant K equal to 80? If you don't understand what a dielectric constant, how it is coming in Coulomb's law, then please go to my Coulomb's law lecture. There I have explained. Okay, this is not explained in anywhere. Okay, this kind of things will be not explained of this dielectric etc because they will just derive 1 by 4 by epsilon naught q1 q2 by r square only. So the hint is hidden here. What will be the force between these charges when the medium is replaced by another medium? It means that whenever it was here, okay, the medium was some other thing, and next case the same charges, okay, the same charges are there, the charges are not replaced, q and q, and f is equal to question mark, and this is the medium, another medium of dielectric constant K is equal to 80. So how much will be the force experienced by these two charges in this case? So it means that whatever the thing is that it has been changed, the medium has been changed. Whenever the medium is changed, it means that this was in air. Please remember, this was in air or vacuum. So this was in air, okay, this was in air or vacuum. Please remember this one, okay. So it was in vacuum. So we know the formula for air, force is equal to 1 by 4 pi epsilon naught q1 q2 by r square is there. Okay, now for this q1 is q, q2 is also q, so this I will not write. And what is r? That is my 1 square, because the distance is 1. Then how much will be this one? So this will be f is equal to, I will write this as k, okay. So this is my k, not r, anyways. So this is my k, and this will become q square. So I will call this 1. So this is in air now, okay, air. So this is the value. Now how much, what is the formula of the force, Coulomb force in any medium? The formula for force in any medium is F is equal to 1 by 4 pi epsilon naught K into K, Q1 Q2 by R square is the formula. So here I will write 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught I have written as K. So I will write this as K divided by, okay, so this I have written as K divided by, what is the value of K here is 80. And what is K? This K is dielectric constant, okay. This K is my dielectric constant of this medium, and it is 80. So this is Q1 is Q, Q2 is also Q, it will become Q square, because the charges are not interchanged, charges are not replaced, and the distance is also not changed, so it will become 1 square. Then how much is this one? This will be K by 80 Q square. Okay, this is in medium. Now how much will be the force in medium? So in medium, in second medium, this much is the force. But if you see here, there is K Q square. Okay, there is K Q square. Now how much is the K Q square from this? It is F of air. So the F of medium is equal to K Q square is, okay, this is 1 by 80 and this is F air. So this is the force in the medium. It means that the force in this medium is reduced by 80 times. Okay, by 80 times reduced ho gaya. Okay, so this question is very important. Okay, this next question is very important in case of establishing the knowledge, okay, in case of establishing the knowledge and the concept. So it says that the two charges, okay, this was asked in 2000, not asked, it was 2017 supplement, I mean the sample questions, okay. In 2017's examination sample question, this question was given. So in next question I will solve another question similar to this one. The two charges Q and minus 3Q are placed on x-axis. So x-axis means this anywhere, okay. Even this question may ask z-axis also, y-axis also. Don't worry about this, simply they are in a line, okay. Axis is a line separated by a distance d. These two charges, okay, this Q and minus 3Q are separated by a distance of d, and where a third charge 2Q be placed such that it will not experience any force. Okay, so to solve this, what we need to do, I have to put the point, but where, okay, where I should put the point? There are so many points here, here, okay, so I have to decide where I should put the point. Okay, so you have to remember one thing. Okay, so there is logic as well as the theory that I am going to explain, but what you need is better you mock these two things. Okay, I am going to give this. So if these two charges are, say, if you see this is my positive charge and this is my negative charge, it means that they are unlike charge. Okay, just write if the charges are unlike, okay, please remember, if the charges are unlike, okay, if the charges are unlike, then the point is outside the two charges. Okay, if the charges are unlike, then the point is outside the two charges. Which point I am referring here is the point at which the force is zero, at which such that it will not experience force. It means that there is no force. So this is the point where there is no point. So I have to find the point where I should place 2Q charge so it will not experience any force. So there are many points. There are points between this charge and this charge. There are points this side. There are points this side. Okay. So then the point is outside the two charges. It means that if they are unlike charges, if one is positive, if one is negative, and if one is negative and if one is positive, then the point where the force is 0 is not between these two charges, it is outside the two charges. Okay, so outside the two charges, and there are regions where which side, this side or this side. So for that, the point is near smaller charge. Okay, smaller charge, you have to remember this one. Okay, the point, okay, the point is near the smaller charge. Now, which one is a smaller charge? This is positive q, this is minus 3q, this one is my smaller charge. Okay, please do not think that this is negative, so it is a smaller charge. Okay, this negative means this is a negative charge, it is not a smaller. Number is 3, so this one is big, this one is smaller. So point where it should be near the smaller charge. Since these are opposite charges or unlike charges, the point is outside the two charges. Okay, now in the next question I will tell what if the charges are positive, I mean the like charges, either positive or negative. Okay, first let us do this. So point, I have to make a point near the smaller charge. So this is the point where I will place 2q, and here force is equal to 0. Okay, so why I have to keep here is because this is positive and this is also positive. What they will do is they will repel each other. Okay, this charge will be repelled in this direction. Okay, this is force between these two, and because of this minus charge and plus charge, this force will be in this direction. Okay, this is force on 2q due to q, and this is force on 2q due to minus 3q. So this part is not important to write. I am just saying why it is here. Now see, if it is plus, if it is my plus 2, if it is minus 2q, then you should not worry. Okay, this do not depend upon this system. Okay, either it is positive charge or negative charge, follow this things. Okay, these are very important concepts, these are very important points, especially for bio students. Okay, if you understand this, then in couple of lecture we are also going to find electric field 0, we are also going to find the electric potential 0 in the next chapter. So there also we will be using the same concept. Okay, so if you understand, then it is very simple. So let me have, okay, so let this distance, okay, let this distance from this q to this 2q is my x. So at this point the force is 0 because force between this and this is in this direction, force between this charge and this charge is in this direction, acting like this, and here is 0. So what we need to write is, so force on 2, okay, force on 2q due to q should be equal to force on 2q due to minus 3q, and then at this point, and then only at this point the force will be 0 because one force is going that side, the other force is coming that side, pull ho raha hai. So if they are equal, then what will happen? If they are equal force are there, equal magnitude of force are there, then there will be net force is 0. It means that the system is in equilibrium or it will not experience any force. It means force is 0, so shows that it will not experience force. And we want to find this x because at x distance from q the force is 0. I have to write here, please remember, and opposite. Okay, This is very important diagram है बुझ्दै छ नि यो diagram board मा if somebody asks and if you keep this point here then your marks will be half marks will be gone. Understood? So these are very important. So force between this and this should be equal to force between this and opposite, and then there will be no force. So or how much is the Coulomb force? It is 1 by 4 pi epsilon naught q1 q2. It means that q1 is 2q into q2 is q divided by r square. R is the distance between 2q and q. Here the distance between 2q and q is x. So this will be my x square equal to 1 by 4 pi epsilon naught q1 q2. This is 2q into 3q divided by x square, r square. How much is the distance? This distance is d plus of x. Is the distance between minus 3q and 2q, that is d plus of x whole square. Now please remember one thing, that I am not putting negative sign of this charge. Please remember that one also. Write a note whenever you calculate what force or electric field, you don't need to put the signs of the charge. Please make sure that you understand this. Okay, you don't need to put the charge, the symbols of the signs of the charge. Now this 2q will cancel with this 2q, okay, and this 1q will cancel with this q, and this 1 by 4 pi epsilon naught cancel with 1 by 4 pi epsilon naught. Then what is remaining here is nothing is here. Here is 1 by x square should be equal to, how much is this? 2q cancels, q cancels, there is 3. So this is 3 divided by d plus x whole square. Now to solve this, a good mathematics student will solve, a good teacher like me will solve with the quadratic equation, but the smart student like you will solve it in shortcut form. Okay, so what is the shortcut form here? Square root. Take the square root. Okay, taking square root both sides, under root 1 by x square should be equal to under root 3 by d plus of x whole square. So what do I get is, I will get, this will become root 1 by root x square equal to root 3 by root d plus x whole square. So root 1 is 1, root square, root cancels, this square, this root cancels, then what do I get? So I will get, this is 1 by x equal to root 3 by d plus x, and we are finding x. So you bring this here, what do I get? I will get d plus x into 1 is same equal to x root 3 cross multiplication, and I will get, this is x, you bring this here, minus x root 3 equal to minus d, and or take this x common, this will be 1 minus of root 3 equal to minus d, and we need x, so x is equal to minus d divided by 1 minus root 3. And let me rationalize, because denominator, I don't want a root in the denominator. So whenever you rationalize it, what you need to do is multiply with 1 plus root 3. Here also 1 plus root 3. So this is a plus b, a minus b. What you will get? A square minus b square, or x is equal to minus d. Okay, there is 1 plus of root 3 divided by a plus b, a minus b is a square minus b square. So a square is 1 square minus root 3 square. Okay, so this will be minus d 1 plus root 3 divided by 1 minus of 3. Then this will become minus d 1 plus of root 3 divided by minus 2. This cancels and I will get the answer as d by 2 1 plus root 3 meter. So at what point the force is 0? The force is 0 at x equal to d by 2 1 plus root 3 from a smaller charge. From the charge q you have to write this. Okay, from this charge q. Okay, now let us go to the next problem of similar kind in which I will take both like charges. Okay, so this question is similar to the first one. Okay, and it says find the point at which a positive test charge q0 to be placed. I have to find the point at which I have to place positive test charge q0 so that it will not experience any force. Okay, so that it will not experience any force, that is force is 0, due to a system of two charges minus 81q and minus q separated by a distance d meter, separated by a distance d meter. So unlike the first question, here the charges are like charges. Now where the point should lie for the like charges? Okay, so if the charges are like charges, then the point should lie, then the point should be between the two charges. Okay, then the point should be between the two charges. So between the two charges means not here, not even here, between this charge and this charge, in between this. So if they are on like charge, point should be outside. If like charge, point should be inside. But inside where? Towards bigger or towards smaller charge, the second point is same, the near the smaller charge. In first case also it was near the smaller charge, but outside because of opposite charge, unlike charge. Here also the point should be inside between the two charges near the smaller charge. So the smaller charge, which is my smaller charge, the smaller charge is my minus q. Okay, this is my minus q. So I have to place a point somewhere here where force is equal to 0 and this is positive q0 charge is there. Now what happens is, this is negative, this is positive, it will attract in this direction force, and this is positive, negative, this is positive, so it will also attract. So here it will be the point. If I do it here, then what happens is, this is larger charge, this is a smaller charge. If this point is here, then it will attract that side with very large force, so their force will not become 0. But whenever you come here, the force of attraction reduces, and at this point the force of attraction between this and this will become 0. Okay, and become equal. One is in this direction, other is in this direction. So we have to place this at near the smaller charge. Okay, if you want to have the detail of this theory, then you can always comment me. Okay, so the point should be outside, point should be between the two charges near this. So let this distance here be my x. So again the force on q0, due to minus q will be equal to force on again q0 due to minus 81q and opposite. Please remember, these charges should be equal and opposite. So the forces should be equal and opposite. So Coulomb's law again, it is 1 by 4 pi epsilon naught. Okay, q1 is my q0, q2 is my q divided by r square. R square is the distance between q0 and minus q. q0 and minus q distance is my x square. So again, please remember, whenever you calculate force, no need to put the sign of the charge. This will be equal to then 1 by 4 pi epsilon naught Q1 into Q1, Q1 is Q0 into Q2 is 81Q divided by how much is the distance? Distance is between this charge and this charge. Is how much? You take this whole distance d and you subtract this distance, okay? Then you will get this distance. Whole distance minus of this distance is d. So this distance is x. So d minus x, you get this. So this is d minus of x whole square. Okay. So q0 and q0 cancels. This q cancels with this q. Then 1 by 4 pi epsilon naught cancels with 1 by 4 pi epsilon naught. And I will get what is there? 1 divided by x square is equal to 81 divided by d minus x whole square. Okay, next step, take the root. If you take root like this, what will become? This will become 1 divided by x is equal to root 81 is 9 divided by d minus x. Okay, so by solving this, you will get the value of x. So this is all about this type of question, and you have to understand this, how to solve, where should be the point, etc, etc. Okay, if you don't solve this question, then you may not understand this. You can easily solve where the charge to be placed, there is a no force. Okay, total force is 0. But what if this kind of question will be asked? Question says the 2 point charges Q1 and Q2 are placed at a distance d apart as shown in the figure. Okay, as shown in the figure, the Coulomb force on the point charge Q0 is 0 on the line joining as shown. Okay, the Coulomb force at Q0 is 0. There is no force F equal to 0. Write two conclusions that you can draw. So if you just solve the numericals, then you cannot write this conclusion. Okay, so the conclusion is that we have studied when the point should be outside, when the point should be outside, when the charges are unlike, then we can say, okay, the point is outside. Here this point is outside. The conclusion is that the Q1 and Q2 are opposite to each other. One conclusion, Q1 and Q2 are unlike charges, because we have already studied. That is why I was saying, right? So if Q1 and Q2 are unlike charges, then point is outside. We have studied. So the Q1 and Q2 are unlike charges. Then next, what could be? Think. Yes. We place the charge at or near the smaller charge. It means that this is Q2, which should be smaller than Q1, because I will always put the point or the charge near the smaller charge. So it means that Q2 is smaller than Q1. So these are the two conclusions. Then we can make 2000.